Okay, so here's what we're going to start off with. So this is 16.2a. Tomorrow we'll do 16.2b. This is all about going to be about parabolas. So the I can for today is I can graph parabolas. Parabolas. Okay, as conic sections and identify important features. And if you flip through the notes, you'll notice that for every one of the conic sections, we're going to do the same thing. The first day, we're going to learn how to graph them, learn where they come from their definition. And then the next day, we're going to take the key features and we're going to figure out, hey, what equation would have produced this? Okay, so we want to name the first four conic sections. We've already studied one of them, but we didn't call it that. Okay, it's a circle. The next one, of course, the one we're going to cover today is a parabola. Then what were the other ones? Ellipse. Okay. Ellipse and then hyperbola. Okay. Hyperbolas are the most complicated ones. Hopefully by the time we get there, you find they're not too easy. We can do some things to kind of make them seem a little bit easier. But the thing we want to start with each one of them is a definition. Okay. So they all come from a definition, and here's the definition for a parabola. So a parabola is the set of points on a plane that are equidistant from a given point and a given line. So we need a given point and we need a given line in order to make the parabola. The given point is called the focus, which is not something we talked about when we studied parabolas before. And the given line is called the directrix. Okay? And I've got a short animation here to show you where this comes from. So we need points, and I'm going to start off over here. We need points that are equidistant from this thing right here, which is the focus, and this thing right here, which is the directrix. So probably the easiest point to find to start off would be that right there, because they're exactly the same distance from each other. And then if I put a point over here, I have to come, so I measure distances straight off that line, and then I measure straight over here, okay? And then another one, I could probably put one right here. So I'm going to go straight down to here and then over to here. And so these points right here, those will define the parabola. And I can do the same thing on the other side. So I'm going to show an animation, a really quick animation for this, and then we'll come back and we'll derive what the equation would be. So I'm going to flip over here. So I've got this already up, and I'm just going to hit play. So you can see that circle, each one of those blue lines is a radii. And hold on, I'm going to play it again.
No, I didn't understand.
Okay, so let me back up. Okay, so that blue line, this dot right here is the focus. Okay, so we've got the focus right here. This is the directrix. And these blue lines are both radii on a circle. So this blue distance is exactly the same as that distance right here. So I'll let it play again just a little bit. And then I'll stop it there. So the same thing is true here. So we've got the focus right there. We've got the directrix over here. This point is at the center of the circle. So this blue distance is exactly the same as that distance. So the distance from the point on the parabola to the line, the directrix, is exactly the same as the distance from the point on the parabola to the focus. So let me do this, see if this works. There's that one. There's that one. And you could physically make one of these. They just take a really long time to get. Okay, so I'm going to leave this right here because this picture I'm going to transfer back onto our paper, onto our notes. And we're going to use the distance formula, and we're going to come up with the equation for a parabola that looks like this. Okay? So what we want to notice is the center of the circle is the same distance from the focus, same distance from the directrix. Okay, is everybody okay with that? You can go back and play around and watch this all you want. Okay, so here's what I'm going to do. I'm going to label this as D1, and I'm going to label this as D2. And this point right here, I'm going to label that as just any old XY point that's on the plane. So this point is at 0A, which means we didn't go right or left. We just went up this distance right here. So that's where the focus is. And the directrix is the line y equals negative a, because remember, it has to be the same distance. So we went up here a units. We went down here a units. So this point right here is definitely on the parabola. And as we slide one way or the other, any point on the xy plane could be represented by an xy pair. And we want to find the distance between this xy pair and the focus. So I'm going to write d1 equals, and then I'm going to write a big square root. So this would be x2 minus x1. So that's going to be x minus 0 quantity squared. And this is going to be y2 minus y1. So this is going to be y2 minus y1, which is a. So I'm going to put an a right there, and then I'm going to square that. Is everybody okay with that? Okay. So I'm going to simplify this just a little bit, and I'm going to write the square root of, this is x minus 0, so this is just going to be x squared. And this is plus y minus a quantity squared. And just a quick reminder, remember, you can't take the square root of each piece separately. Square roots don't play well with adding and subtracting. So you've got to just leave it like this for now. Everybody good with that? Okay. D2 then would look like this. It's the distance from here straight down to there. Now, if we go straight down here, I'm going to put a point on the line, and that point on the line would have the same x-coordinate as the x-coordinate of the point straight above it. And what would the y-coordinate be if it's right on that line? Negative a. Okay, whoops, let me make that look like an a. So now I'm going to find the distance between, the distance between here and here. So that's D2. So I'm going to do a big square root. And I'm going to do x2 minus x1. So that's going to be x minus x, because they're the same horizontal distance from the origin. Whoops, this needs to be a plus. Plus y2 minus y1. And y1 in this case is a negative a. So I'm going to clean this up just slightly. Everybody okay with that? Okay, so this is D2 equals x minus x would be 0. So I'm going to have a big square root. And then this is just going to be 0 squared, so I'm not going to write that. But I am going to write y plus a quantity squared. Is that okay with everybody? Okay. Could I take the square root off this? Does the square root cancel the squaring? It does, but I'm not going to do that right now, and you'll see why in just a second. So the definition says this. The parabola is the set of points that are equidistant from a given point called the focus and a given line called the directrix. We've got the two distances. Now we just need to set them equal to each other. So we're going to do D1 is equal to D2. These two things, I'll highlight them. This has to be equal to that. So this is going to be, let's see, square root of x squared plus y minus a quantity squared would have to equal y plus a quantity squared. You doing okay so far? This is the ugliest one we'll do. We're going to square both sides. We don't like the square root. We've run into that before. We actually ran into this when we were coming up with the equation for a circle. So this is going to be x squared plus y minus a quantity squared equals y plus a quantity squared. And now we just need to be careful, and we're going to come up with the equation. So I'm going to zoom in on this. This is going to be x squared. If I square this binomial, so I'm going to get a perfect trinomial squared, I'm going to get a y squared. I'm going to get a minus 2ay. And I'm going to get a plus a squared. Because remember, when I multiply these together, I'm going to get a negative ay and another negative ay. Those middle two terms are going to add up, and we're going to have negative 2ay. Do I need to show the work for that? We're okay? Is that a yes?
Yeah.
Okay. So y minus a quantity squared would be y minus a times y minus a. So we're going to get y squared minus ay, and then plus a squared. Everybody good there?
I remember that.
Okay.
Sorry.
D.
My bad.
What's that? Right here?
On the upper one, y minus a squared would be y minus a times y plus a.
No, it's the same thing. We repeat it. It gets multiplied by itself. Okay? This one's going to be exactly the same thing, but everything's going to be a plus. So notice what happens on this side. This is going to be a y squared. This is going to be 2ay, and then this is going to be plus a squared. Anybody notice anything that's the same on both sides? Mason.
Y squared and A squared.
We've got a y squared on both sides, and we've got an a squared on both sides. So if I just cancel those out, this cleans up really quickly. This is x squared minus 2ay equals 2ay. And we probably ought to collect the like terms. Let's move these guys over to this side. So this is plus a 2ay. So here's what I get. X squared equals 4ay. And that's what we're after. Okay, now I'm going to shrink this back so it's full size so we can come off to the side here. And yes, I realize this is a ton of stuff to figure out, and this is the first time you've seen a conic section. Introducing the way things work and getting used to them is really difficult. So today's going to be kind of a brain bender. After that, it's going to start getting easier and easier and easier because you're going to see the same type of things again.
Heck yeah.
So we start with the point 0, a, which we did. That's the focus. And we start with the line y equals negative a. That's the directrix. If we do that and follow this process through, saying those distances have to be the same, then the equation of the parabola is this. X squared equals 4ay. And you'll notice over here that the vertex is exactly halfway in between. So the vertex is right here. So it's halfway in between the focus and the directrix. So the vertex has got to be at 0, 0. And it says blank is the distance from the vertex to the focus and from the vertex to the directrix. So how far is it from here to here and from here to here? If this is 0a, what is it? Just a. So a is the distance from the vertex to the focus and from the vertex to the directrix. Okay, the focus, and this is true of all conic sections, the focus will always be inside the curved part of the conic section. So what we get here is we get a shape that looks something like this. And the focus is right there. It's on the inside of the curved part of the conic section. And the conic section wraps around the focus. So here's the summary. All of that stuff is great. If we see an equation that looks like this, its vertex is at 0, 0. It opens up. And then we just need to know, oh, how do we find where the vertex is? How do we find where the directrix is and stuff like that? What if the only thing that changed on this was there was a negative in front of the 4ay? Does anybody want to take a guess at what would happen? Luke, what do you think?
I think it would open down.
Very good. Opens down. It would still have the same vertex. The vertex would still be 0, 0, but it would open down instead of opening up. Okay? So I'm going to slide down here, and we can do the same thing if we turned it to the side. So say we tilted it 90 degrees clockwise. This would be a vertical line. So this is x equals negative a. What's the x coordinate of this focus right here?
A.
That would be a. Okay? So the focus is going to be at a, 0. The directrix is going to be x equals negative a. And the vertex would still be at 0, 0. Which way would it open? Vertex is right here. D, what do you think? Yeah, it would open to the right. It's going to be a parabola that looks something like this. So it opens right. Does anybody want to take a guess at what the equation would be? Mason's got his hand up. Anybody else? Wilson? Anybody else? Okay, take a look at these two drawings. Let me slide this down so you can see the difference. All we did is took this and rotated it 90 degrees. Everything that used to be an x is a y. Everything that used to be a y is now an x. Wilson?
Would it be y squared equals 4ax?
Very good. That's what it's going to be.
Ow.
Okay? So here's the summary. Y squared equals 4ax. Vertex is at the origin and opens to the right. What if we put a negative in front of it? Opens to the left. Okay, now, this next box is important because once we know this stuff, then we can start graphing these and we can graph them really quickly and have a lot more information about the useful parts of a parabola other than just when we were launching things off cliffs and seeing what their path would be and doing projectile motion and stuff. Okay, so we need to know the basics for parabolas that open horizontally and vertically. And if you want to, you can memorize these formulas. So if you want to memorize this formula and you want to memorize that formula and this formula up here, where was it? All the way up here, and that formula right there, you're totally welcome to memorize those. Okay, or you can just remember this. The focus is always inside. The directrix is outside. Each of them are A units away from the origin along the axis of symmetry. Now, we've talked about an axis of symmetry before. There's an axis of symmetry, okay? Top part, bottom part. There's an axis of symmetry, left side, right side, okay? Yeah.
Could there be an axis of symmetry that's like y equals x and then it would be like a circle?
There could be. If you get into a really advanced class, honestly, I've never done one, but I know they exist. You can get them so that they tilt. They're ugly to work with, but the same idea is true. Okay, excellent question. Okay, so down at the bottom, let's actually graph a couple of these and I'll show you how easy this is. Okay, it says determine which direction it opens and then graph the parabola and all its key features. So we'll talk about what those key features are. So I'm going to zoom into about that big. Okay, so opens. Which way, crew? Opens up. Okay, vertex. 0, 0. Okay. Then what I do is I take this. That number right there is really important. 8 is equal to 4a, and I need to know a because a is the distance from the vertex to the focus and the vertex to the directrix. So I know I've got a vertex right here. What I need to do is I need to figure out how far do I have to go to the directrix and to get to the vertex, or sorry, the focus. So I'm going to divide both sides by 4, and I get 2 equals a. So it opens up. So the focus is going to be inside the curved part of the parabola. So I'm going to put the focus right here. The directrix is outside and it bends away from there. So the directrix looks like this. So the directrix is y equals -2. The focus is 0, 2. The vertex, of course, is 0, 0. We've got that labeled over here. In fact, I'm going to put it down here, 0, 0. You can't always put it right next to it just for space and stuff like that. Now, you ready? Okay. There's one other important thing that we can use on here, and it's a Latin word. Okay. It's the latus rectum. Okay. The latus rectum is 4a units long. So it's the same as this number right here. And the latus rectum helps us find 2 points that define the shape of the parabola. Okay, and the reason it's called the latus rectum is in Latin, latus means side, and rectum means straight. So we're going to go straight to the side, and if it's 8 units long, I'm going to go 4 units on this side, and I'm going to put a dot. I'm going to go 4 units on this side and put a dot, and this is the parabola. Put arrows on the end. If I wanted to label the points of the latus rectum, whoops, I'm going to change colors here. Latus rectum would be 4, 2. Get that to change colors. 4, 2 and -4, 2. Those are all the key features of the parabola.
What the?
So if you graph 3 points on the parabola, the vertex and the endpoints of the latus rectum, and you graph the focus point of the parabola, and you graph the directrix, those are all the important features. Okay, we've got the right vertex, we've got the right shape because we've spread it out the right amount because we went 4a in total each in all. Okay, so we're going to come over here. We're going to take a look at the next one. I'm going to ask Crew, which way does this one open?
To the right.
It opens right. Okay, Abby, what's the
I know
vertex?
that.
It's the origin, 0, 0. And then we have to figure out what A is. So we take this number right here, and we set it equal to 4A. So if you want to do the algebra, that's totally fine. If you just want to write down that A is 1, that's totally okay with me.
Oh, that's-
Everybody good with that?
Yeah, I knew that.
Okay. Vertex is right here, 0, 0. We're going to make this open to the right, so it's going to go like that.
So this,
So Keely, tell me where the focus is if it opens to the right. Where would I put the focus? Or other way, 1, 0, because it opens to the right. So this right here is the focus. This right here is the vertex. And then the directrix would be 1 unit, or sorry, A units in the other direction. So that would be 1 unit in the other direction. So this is going to be x equals -1.
I know this.
And then let's put these points on here. There's the vertex. And then the lattice rectum is straight across. The endpoints are straight across from the focus. So I'm going to go 4 units in total. So 2 units in this direction, 2 units in this direction. And here's what it looks like.
Wow.
Hold on. We'll label these. The focus is 1, 0. The vertex we've got labeled up there. And this is 1, 2. And this one is 1, -2. We've got all the important features labeled there. Yeah.
Can you just think of it as like there's a circle, you know, and the circle has to have a radius of 2 somewhere, or the same radius at a point. So if you go exactly 2 up or 2 down, you have to go exactly 2 the other way into the.
You
No.
let's see. Yeah, you could. So I think so. Wilson's just noticing something.
It's like a right
If you
angle.
think of a circle centered right here, you'd hit the lattice rectum here, and you'd hit the directrix right there, and then the vertex would be right here. I would say that works. I'd want to look at it a little bit more, but yeah, I think you're on the right track.
No,
Okay.
Wilson's wrong.
You think so?
Yeah.
All right, flip the page over.
It's easier if you know you just have to go like up 4 and right 4 instead of.
No, I think
I
it's
just
easier
make sure
to
it's
do
worth remembering that, because we're going to take it. We're going to change where they are. Okay, so here's a diagram that has all the important features of a parabola on it. So we've got the vertex, we've got the focus, we've got the directrix, and notice the parabola is made up of just the stuff in pink right here. Okay, this distance is A, like we've talked about before, and the distance, the length of the lattice rectum is 4A. And again, like we were saying before, you can turn it so it's left, right, up, down. You can even, if you wanted to, in advanced courses, you can take this and you can tilt it pretty much any direction that you want. So Lizzie earlier was saying, could you tilt it so it's on a 45-degree angle? Absolutely, you could do that. Okay, gets a little uglier, but you can do that. Okay, so if you keep this mental picture in your head, it doesn't matter which direction it's turned. We should be able to look at this and we should be able to graph these really quickly. So I'm going to zoom in on this. And I'm going to look at it and say, hey, wait a minute, y is squared. If y is squared, it's going to open horizontally. It's going to either open left or right. In this case, it's going to open left.
Yeah, that's
Vertex
0,
hasn't been moved, 0, 0. Now, if you want to write down that 12 is equal to 4a, that's totally fine. What we're really interested in is, what's the size of that number? Not that it's negative. The negative tells us that it opens to the left. What we're interested in is, what is A? In this case, A is 3. So the vertex is at the origin. It opens left, so that means the focus has to be 3 units in here. So there's the focus. There's the vertex. And the directrix has got to be 3 units outside that. So this is going to be x equals 3. This is going to be -3, 0. This is 0, 0. And then how far do I go up and how far do I go down? Half of that distance, right? So I'm going to go up 6, put a point here, down 6, put a point here. I'm going to change colors just so we can see for sure what the parabola is. The parabola is going to look like this. Okay. Any questions? Okay. I'm going to give you about 1.5 minutes to do this one, so go.
Wow, this one's kind of a little bit silly. This one. I'm gonna make it Oh, wow.
And feel free to use decimals if you want.
Wait. Ah. I think I've done it.
It's well, crew.
Very good job.
Did you say me as well?
Yep.
So formal.
When are we gonna learn about how like rockets take off?
Oh, that's tomorrow.
Actually,
That it feels like it. Like we're doing stuff like this. This is
Okay.
like
Raise your hand if you're done. Okay. Did I get it right?
yeah, that's what mine looks like.
We're good there? Did you label all the key features?
Yeah, I did actually.
What didn't you label, Dane?
label.
I didn't label anything.
I labeled.
Did you get the right graph?
Yeah,
On a test, are you going to label it?
probably.
On an assignment, you going to label it?
Wait, why'd you go over 3? I thought we go over 4.
Oh, crew did it wrong.
This is 6A, or this is 6. So you're going to, the whole thing is 6 units long. So I go 3 one direction and 3 the other direction for a total of 6. Any other questions?
No.
Okay, all right, let's take a look at what happens when we take this and we can move it around anywhere. Now, I'm hoping that this looks kind of familiar. You could memorize a bunch of different formulas and stuff like that, but this will take care of the 2 of them. So if I have x quantity squared, that's going to be a parabola that opens either up or down, and it's going to be determined whether the sign of that 4a thing, that coefficient, is positive or negative. So the vertex is going to be shifted from the origin to h comma k. The thing you want to pay attention to is how much did they change the x before they squared it? How much did they change the y before they multiplied it? So its vertex is going to be at hk. It's going to open up if it's positive 4a. It's going to open down if it's negative 4a. Now there's an asterisk by the next one for a good reason. If you just grab this number and put it first and grab that number and put it second, you're going to get it wrong. The h is always with the x, so this still has a vertex at h comma k, but you've got to grab the x because, or the h because it's with the x. You've got to grab the k because it will be with the y. Then it's going to open. What if it's positive? Which way would it open? Right. So it's going to open right. If it's positive, it's going to open left if it's negative. A is always the distance from the vertex to the directrix. The focus is always inside the curved part of the conic section. So if you can look at the equation and tell which direction it opens, if it opens to the left, you're going to put that focus inside there to the left of wherever the vertex is. Okay, same thing if it opens up or down or whatever. The lattice rectum is 4a units long, and it always goes through the focus, and it's parallel to the directrix, like we saw up here. Okay, so here's the lattice rectum. It's parallel to the directrix. Same thing here. Okay, and the axis of symmetry always goes through the vertex, and it is perpendicular to the directrix. Now, we don't use the axis of symmetry all the time. We don't label it or anything like that, but we know it's there, and we might use it to make sure that we've got the right shape. So this is more along the lines of what your assignment is going to look like. If you can graph these, again, that's the I can statement for today. You can see it down here. I can graph the equation of a parabola as a conic section and identify all the important features. So let's check and see here. Don't say anything out loud. Just think, which variable squared? And what's the sign of that right there? If x is squared, you've got a choice. It's a regular old parabola. It's either going to open up or down. In this case, because that's positive, it's going to open up. What's the vertex? Don't say anything out loud. We're going to change the opposite of this amount in the x direction. So this is going to be 2 comma, and then the opposite of this in the y direction. So that's going to be 2 comma negative 1. And then we'll grab this 8, and that's equal to 4a. So that means a is equal to 2. So the vertex is going to be at -2, -1. So -2, -1. So we're right there. That's the vertex. And then it opens up, so we've got it curving around right here. So the focus is going to be 2 units on the inside. So we'll put a 2 right here, up 2 right there. And then 2 down, that's going to put us right here. So the horizontal directrix right here, that's going to be y equals -3. And then the focus is right here. And then the length of the lattice rectum is 8. So we're going to go 4 units in this direction. So we're going to go over there, and then 4 units in this direction over there. And then I'm going to color code this. So this is a point on the parabola. This is a point on the parabola, and that is. So it's going to look something like this. And then I'll label each one of these points. So this is the focus, and the focus is at 2 comma 1. The vertex is at 2 comma -1. There's our directrix right there, y equals -3. And then this endpoint is at 6 comma 1, and this endpoint is at -2 comma 1. Okay, so we've got all those, and let's take a look at the next one here. Okay, y is squared, so it's either going to open left or right, and because this is negative, it's going to open left. So opens left, and that's because of the negative sign right here. And then let's see, we've got to be careful on the vertex. The vertex is going to be the opposite of one with the x, so that's going to be a -3. Opposite of the one with the y, so that's going to be a +1. So let's see, -3 and then up 1, so we're going to be right there. And then let's see, we'll just do the 4a. So a is equal to 1. So we're going to go 1 unit this way, and that's going to be the directrix, because again, it's going to open to the left, and 1 unit this way, so that's going to be the focus. And I'm going to zoom in on this just a little bit. So this is going to be x equals -2. And let's see, we go 4 units altogether. The length of the lattice rectum is 4, so we're going to go up here, 2, and down here, so the whole length is 4. So we're going to go from here to here to here. Those points are on the parabola, and let's label those. So the focus, let me get this out of here, the focus would be -4 comma 1. The directrix is x equals -2, and then the vertex right here, vertex again is -3 comma 1, and then this point would be -4 comma 3. And then this point would be -4 comma -1. And we've got all those points there, all of the key points. And then we'll come down here and take a look at the last little bit of this. It just says, what adjustment would we need to make after these changes are made to the equations? All we have to do is describe, we don't have to graph. So you'll notice that this is A star. It's just like A, except for there's a negative right here. So the vertex is going to stay in the same place. The only difference is it's going to open down. Oops. So opens down. And then on this one, again, we've got y minus 1 quantity squared, we've got x plus 3. So it's going to have the same vertex, but this one's going to open in the positive direction. So this one opens to the right. Okay, and that's all we need to know.